Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is phthalic anhydride, a cyclic anhydride where the two carbonyl groups are bridged by an oxygen atom in a 5-membered ring fused to a benzene ring. Moving on to the next step. When phthalic anhydride reacts with methanol, MeOH, the anhydride ring opens. Methanol acts as a nucleophile attacking one of the carbonyl carbons, opening the cyclic anhydride to give a half-ester half-acid product, one carboxylic acid group, -CoO, and one methyl ester group, COMe, on the ortho positions of the benzene ring. This product A is monomethyl hydrogen phthalate, 2-methoxycarbonyl benzoic acid. Moving on to the next step. PCl3 converts a carboxylic acid, -CoO, into an acid chloride, COCl. PCl3 selectively reacts with the free carboxylic acid group rather than the ester. Therefore, product B is methyl 2-chlorocarbonyl benzoate, one COCl group and one COMe group at ortho positions on the benzene ring. And for the final step, methylamine, MeNH2, is a nucleophile that reacts with the more reactive acid chloride, COCl, preferentially over the ester, COMe. The amine attacks the carbonyl of the acid chloride, displacing chloride and forming an amide bond. This gives product C with 1C is equal to O, NHMe, methylamide group and 1C is equal to O, OMe, methyl ester, group at ortho positions on the benzene ring. Product C has C is equal to O, NHMe and C is equal to O, OMe groups ortho to each other on benzene. This matches option B exactly. Why option A fails? Option A shows A, C is equal to O, Cl and C is equal to O, NHMe, which would correspond to product B after only partial reaction, not after MeNH2 treatment. After MeNH2 reacts with the acid chloride, no chloride remains. Therefore, the correct answer is B. Therefore, the correct answer is option B.